All right, strap in, everyone. We're going deep on recyclable metals and sustainable alloys this time, all based on cocktail party chemistry, episode 95.
Yeah, a whole pile of research here. Looks like we're peeking into the future of materials science.
Definitely not your everyday metals, from the looks of it.
Mm,
High performance A&D, easy to recycle. How does that even work?
it's pretty amazing, actually. Scientists are figuring out how to make metals that can be melted and reused over and over.
God, they don't get weaker or anything.
Nope, not at all. Strength and durability are still there.
So, like, imagine a spaceship. Tough enough for space travel, but when it's done, you just melt it down and make something new.
Exactly. Minimal waste. A true circular economy for metals. That's the goal.
That makes me think of this closed-loop recycling idea. One source called the Holy Grail of sustainability. What's that all about?
Think of it like nature's own recycling system. Only for metals. We reuse what we have instead of digging up more.
Less energy, less impact on the planet, right?
All of that. And it's not limited to just spaceships. These new alloys, they're being designed for all sorts of things. Giant aerospace stuff down to the tiny circuits in our phones.
Oh, yeah, I read about that. Alloys that are super light, BUT, also really conductive.
Yeah.
Perfect for smaller, more powerful devices.
Exactly. Different uses need different properties. Scientists can really fine-tune these alloys now. Need a metal to handle the heat of a jet engine? Done. Flexible enough for bendable screens, but still strong. They're working on that too.
Like having the perfect metal for every job. But even with all this recyclability, doesn't corrosion still mess things up?
It's definitely a challenge, but research is making huge leaps there too. They've come up with these advanced surface treatments, kind of like a shield. Protects the metal and makes it last way longer.
A suit of armor for metal.
Exactly. It makes things more durable, so we don't have to replace them as often. Less waste overall.
This is really cool. We're getting metals that are not only stronger and more versatile, but also way more sustainable. One source mentioned sustainable metallurgy. Sounds like a huge step in that direction.
It's all about making the entire process, from mining to manufacturing, more eco-friendly. Less greenhouse gases, using less water, and finding cleaner energy sources for the industry.
So it's not just the metal itself,
Yeah.
it's how we make it and what happens to it when we're done with it.
Precisely. It's a whole new way of thinking, and it could totally change industries that rely on metals. It's a path to a much greener future. It really is about the whole picture, how we use and produce metals.
You know, it's funny. When I think of metal, I always think heavy, clunky.
Yay!
But this is different. It's strong, sure, but also adaptable. I'd even say elegant, the way these new metals are designed.
That's a good way to put it. These advances are changing how we see material science. We're going beyond the old limits of metallurgy. It's like we can sculpt metal atom by atom to get properties we never had before.
Makes you wonder what else we'll be able to change about materials in the future, right? Like, what's next?
Oh, it's a very exciting time to be working in this field. We're on the edge of a materials revolution. We can design them to be functional, sustainable, even responsive to their environment.
Responsive like those shape memory alloys one source talked about? Sounds like science fiction.
Shape memory alloys are really interesting. I can remember their original shape even after being deformed.
Hold on, so if you bend or twist this metal, it'll just like spring back to how it was.
Well, not magic exactly, but close. The most famous one is nitinol, made of nickel and titanium. It changes its phase when heated past a certain point.
So it's got a reset button built in.
That's a great way to think about it. It's already being used in some amazing ways, especially in medicine. Stents that can be put in blood vessels, all compact, then expand to full size once they warm up to body temperature.
That's wild.
Yeah.
And it's just because of how the metal itself works.
Right. And not just stents. Robotics, aerospace, self-healing structures, even energy harvesting devices, shape memory alloys are being looked at for all of that.
The idea that we can program a material to change shape like that, it's amazing.
It really shows how materials science can tackle complex problems and make the world more adaptable.
Adaptability keeps coming up in these sources. One even mentioned tailoring metal properties at the atomic level.
That's nanotechnology. Scientists working at the nanoscale, a billionth of a meter. At that size, materials act differently than they do in bulk.
So like a tiny speck of gold would act totally different from a gold bar.
Exactly. It opens up so many possibilities. We can create materials with better strength, conductivity, even catalytic activity.
It's like a nanotech gives us the tools to make super materials.
That's a good way to put it. And it's impacting so many industries. Medicine, electronics, energy, environmental science, the list goes on.
We're starting a whole new chapter in the story of materials. But we can't forget the environmental impact of all this. One source talked about green chemistry in making sustainable alloys. What's that about?
Green chemistry is about designing products and processes that use and produce the least hazardous substances possible. For sustainable alloys, it's finding ways to make and recycle them with less waste, pollution, and energy use.
So it's like thinking about the entire life of the metal from beginning to end and how it affects the environment.
Exactly, and it has to be economical too. We need solutions that work on a large scale, not just in the lab.
Sounds like a tough balance, but a crucial one if we want these innovative materials to have a future.
Absolutely. That's why there's so much research on cleaner, more efficient, and less wasteful ways to produce and recycle metals.
Okay, so we've talked about the cool stuff these new metals can do and how we're trying to make them sustainably. Well, what about cost? Are they actually affordable? I mean, it all sounds great, but can everyday people actually use them?
That's the million-dollar question. Researchers and industry are trying to figure that out. Some of these advanced alloys are pretty expensive to make, especially in large amounts.
So are they only good for niche things then, like aerospace or high-tech manufacturing?
Not necessarily. One of the main things pushing this field forward is making them more affordable for a wider range of uses.
That's good to hear. A materials revolution needs to help everyone, not just a few, right?
Absolutely. And there are signs that's happening. Research is advancing, production's getting more efficient, and prices are starting to come down.
So maybe someday these super strong recyclable metals will be in everyday things. Cars, appliances, buildings.
I think so. That's what's really exciting. These materials have the potential to change how we live and work and interact with the world. They can make our future more sustainable, efficient, and resilient.
Feels like we're seeing a whole new era in material science unfolding, you know?
Yeah, it's an exciting time to be watching this field, that's for sure.
One thing I noticed, the innovation isn't just on a big scale. It's happening at tiny levels too. Micro, even nano.
Right. A great example is the development of high-entropy alloys.
Okay, gotta admit, that name's a little intimidating. What are those?
Well, usually alloys have one or two main elements, plus a bit of others. High-entropy alloys are the opposite. They've got 5 or more elements, all in roughly equal amounts.
Like a metal mix and match?
Exactly. And the weird thing is, this mix often forms one stable phase, and it has some really cool properties. Super strong, tough, corrosion-resistant, even at high temperatures.
Sounds like the ultimate metal.
Kind of, yeah. They outperform conventional alloys in a lot of ways, so researchers are looking at them for all sorts of things. Aerospace, energy, medical devices, even tools for extreme environments.
It's wild how mixing stuff up at the atomic level can make things so much better.
It really changes how we think about metals, shows we're still learning new ways to make materials and do things we never thought possible.
And pushing those boundaries further, one source talked about biomimicry. Scientists are getting inspiration from nature to make new materials.
Biomimicry is really cool. Scientists and engineers look at nature to find solutions to design problems.
So like nature is the ultimate inventor.
Exactly. Nature's had millions of years to perfect its designs. Like spider silk. Pound for pound, it's stronger and lighter than steel. Scientists are studying it to make synthetic materials that can do the same.
Wow, so we could have clothes or buildings as strong as spider silk someday.
Maybe. Biomimicry isn't just about spider silk either. They're studying seashells, how gecko feet stick, even how some plants heal themselves, all to make better materials.
Amazing how nature gives us such groundbreaking ideas.
Right.
Speaking of which, one source mentioned these perovskite solar cells. They seem to be a big deal.
Perovskite solar cells are definitely changing the renewable energy scene. They could be a real alternative to the usual silicon solar cells, with high efficiency and much lower production costs.
Like the next step in solar power.
Potentially, yeah. Perovskites have this special crystal structure, so they're great at absorbing sunlight and turning it into electricity. And they're cheaper and easier to manufacture, which could make solar power more accessible for everyone.
That's huge, especially with all the focus on moving away from fossil fuels. Any drawbacks to them?
One thing scientists are still working on is making them last longer. Perovskites don't like moisture and oxygen, so they can break down over time.
So, gotta find a way to protect them from the environment.
Yep. Scientists are testing different ways to seal them up and making new materials to make them more durable. It's a hot research area, and they're making good progress.
Seems like every cool new discovery comes with its own challenges.
That's science. It's all about exploring, discovering, and figuring out how to solve problems.
This deep dive's been amazing. I've learned so much about these recyclable metals and sustainable alloys. This field is just exploding with innovation. It can really change our future for the better.
I agree. And it's not just about the materials themselves, it's how we approach them. We need to design, produce, and use them in ways that minimize waste, make the most of what we have, and create a truly circular economy.
It's really cool to see how science and engineering are working together to tackle these big challenges we're facing.
And who knows what amazing things we'll find out next. Materials science is always changing. I can't wait to see what the future holds.
Me too. Well, that wraps up our deep dive for today. Hope you've enjoyed learning about these amazing recyclable metals and sustainable alloys. They have the potential to build a much brighter future.
Maybe this sparks some new ideas for you, got you thinking about things differently. The search for knowledge never ends.
Keep those minds curious, everyone. Until next time, happy experimenting.